Hello, in this video I'm going over the answers for the review for quiz number 10. We begin with the first problem. It says Dr. Hypatia would like to determine if there is a statistically significant difference between her two Math 340 classes. To make this comparison, she will compare the results for exam number 1. Class 1 had 35 students take the exam with a mean of 82.6 and a population standard deviation of 1.41. Class 2 had 32 students take the exam with a mean of 84 and a population standard deviation of 3.63. Can Dr. Hypatia conclude that there is a difference in the mean test grades between the two classes at alpha equal to 0.05. So for this problem, we're testing the difference between two means. And let me just go ahead and correct this because we need to make sure we have the proper subscripts in place. And we need to have subscript 1 here. There we go. So let's go back. And we can see that we have mu1 is not equal to mu2. Mu1 represents the mean for the overall mean for class 1. Mu2 represents the overall mean for class 2. Difference means not equal. So mu1 is not equal to mu2. That's the claim. That's H sub 1. H naught is that the means are equal. We collect all our data for class 1, all the data for class 2 from our problem. And remember, this is a z-test because we are given two population standard deviations. Now let's go ahead and calculate the test point using this formula. Take note that the difference in the population means is always 0. So we plug in our two sample means, 82.6 minus 84, plug in the two standard deviations, and then the two sample sizes. What I'll do is I'll go ahead and calculate this test point using a scientific calculator just to demonstrate how to key in the values. So in the numerator, we use parentheses to encase the difference of the two sample means. And then we want to take the square root and we keep everything inside of the square root. So we have 1.41 squared divided by 35 plus 3.63 squared divided by 32. Select enter and we have negative 2.05 as the test point. This is a two-tailed z-test. So we look up the critical value in table F. Two tails, 0.05, go all the way down to the last value. We get 1.96. At the edges of the critical regions is negative 1.96, 1.96. It's a two-tailed test because we have a not equal. There's no direction. Negative 2.05 is to the left of this critical value, thus it falls in the critical region. So we reject the null hypothesis and we state that there is enough evidence to support the claim. Number 2 says the following. It says that a doctor is comparing the amount of money spent by uninsured patients versus insured patients. She claims that the uninsured on an average spend more out-of-pocket money than the insured patients on a yearly basis. Test her claim using alpha 0.10. And here we are provided with the summarized data. So we have the uninsured patients, insured patients. And the claim, and once again I have to modify this because we need to ensure we have subscript 1 for the mu. So the claim is that the mean for the uninsured patient, which is denoted as mu sub 1, is greater than the mean for the insured patients, which is denoted using mu subscript 2. So mu sub 1 is greater than mu sub 2 is the claim. Since it's greater than, that's an H sub 1 statement. H naught is that the two means are equal. Once again, we have our test point. It's a z-test because we have the two population standard deviations that are given. Mu1 minus mu2 is always 0. We go ahead and calculate, plug this information into the test point. We end up with 2.50. Since we have a greater than, it's a right tail test. We look up the critical value in table F. It's a one-tailed test. So one-tailed. Let me just go back and double check alpha. Alpha's 0.10. One-tailed 0.10. We go all the way down. 1.28. It's a z value. And so that's our critical value, 1.28. 2.50 is greater, falls in the critical region. Thus, we reject H naught. And we summarize by stating there is enough evidence to support the claim. All right, number 3. Once again, we're provided with summarized data for number 3. It says a real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the values of homes. A random sample of the two groups appraised 10 homes. Is there a significant difference in the values of the homes for each group? Alpha is 0.05. Assume the data are normally distributed. If we look at the information here, we can see that we are now given sample standard deviations. Thus, we have to apply a t-test. So the claim, and let me correct the claim here, is that the two population means are different. Not different means not equal. So mu sub 1 is not equal to mu sub 2. That's the claim. H naught is that the two means are equal. It is a t-test because we are given the two sample standard deviations. Now, to find degrees of freedom, we calculate n1 minus 1 and n2 minus 1. In this example, they're both 9. So your degrees of freedom is 9. Typically, you pick the smaller of those two values to be degrees of freedom. We calculate our test point. The difference in the population means is 0, so we're going to transfer all this information. And when we compute, we end up with 2.18. And I've already demonstrated how to perform this calculation using a calculator. Let's look up the critical values. So it's a two-tailed test, 0.05. Two-tailed test, 0.05. We go down to 9. That's 2.262. So we have a negative 2.262, a positive 2.262, but the test point falls between the two critical regions. Thus, we do not reject H naught, and we summarize by saying there is not enough evidence to support the claim. Now, for the third example, we're provided with the following information. So the number of points held by random samples of the NHL's highest scores for both the Eastern Conference and the Western Conference is shown. At alpha 0.05, can it be concluded that there is a difference in the means based on the data? So once again, we're given the difference. Let's go ahead and correct our claim here. So difference means not equal to, that's our claim. H naught is always equal to. It's a two-tailed test. And since we have to calculate the standard deviation, this is a t-test. When we calculate the standard deviation, it's a sample standard deviation. And I want to demonstrate how to perform those computations using Microsoft Excel. So I've already transferred the data. What we need to do is we need to compute first the sample mean. So let's focus on the data for the Western Conference. Wait, this should be, sorry about that. Let me clear this up a bit. This should be Eastern, and this will be Western. Just want to make that clearer. So the sample mean for the Eastern Conference, we type in average, select the values. Let's get the standard deviation. We use the function St. Diva, select the values, and then we can just count the data values. We'll have Excel do that for us. So type equals count. It'll just count all the values. We can do that ourselves, but might as well use Excel. And what's nice about Excel is if you enter your functions in this manner, you can just drag it across and it'll automatically calculate the values for the Western Conference. Let's round to 2 decimal places. So now we have the 2 means and the 2 standard deviations. And I've already transferred them here, so we're going to go ahead and calculate. And we end up with 1.18 after we perform our computations. Degrees of freedom of n is n1 minus, well, first we calculate n1 minus 1, that's 10. n2 minus 1 is 8. We pick the smaller, so degrees of freedom is 8. It's 2 tails, 0.05, and we go down to degrees of freedom 8. 2 tails, 0.05, go down to 8. We have 2.306. That's going to be our left critical value, or being the right critical value is 2.306. Left critical value is negative 2.306. 1.18 falls in between the 2 values. Thus, we do not reject the null hypothesis. There is not enough evidence to support the claim. Thanks for watching the video.